Hello everyone, and welcome to part 2 of this video series on permutation and combination. In this video, we'll understand how to find the rank of a word. Then we will see how to calculate the sum of all n-digit numbers which can be formed using a given set of numbers. Then we will see how to calculate the number of lines, diagonals, triangles, and quadrilaterals that can be formed from a given set of points. Let us begin. Rank of a word. Finding the rank of a word means finding the position of this word in the dictionary when the letters in that word are arranged in an alphabetic order. So let us consider an example and understand how to calculate the rank of a word. Let us consider this word Virat. If you want to find what is the rank of this word, so first what we will do is we'll arrange the letters of this word in alphabetic order. So in alphabetic order the words will be in this sequence A. Then we'll get the next letter as I, R, T and V. So the letter of these words appear in this order alphabetically. Now in order to find the rank of this word Virat, what we need to do is basically count all the words which are before this word Virat. So in alphabetic order, we'll first have all the words which are starting with the letter A. Then we'll have all the words which will be starting with the letter I, then R, then T, and then finally we'll arrive at the word which will be starting with the letter V. Now in this word starting with V, we need the next letter to be I, but alphabetically the next letter will be A. So we'll have to first find all the words which are starting with this letter VA, and then we'll get the next letter as I. So we'll have the words which will be starting with VI. Then alphabetically the next word will be A, but we need the next word to be R. So for that we'll have to first find all the words which are starting with this letter VIA. Then we'll get the words which will be starting with VIR. And then alphabetically the next word has to be A, and we also need the word A. And then finally we'll have the word T. So this will be our final word. So before these words, how many words are there? We need to count them first. So let us start with this first letter A. So to find the number of words which will be starting with this letter A. Now since there are total 5 letters in this word Virat, so we are starting with the first word which will be starting with the letter A. So there are 4 other letters which we need to arrange in these 4 places. So once we do that, we'll get all the words which will be starting with this letter A. So the 4 letters that we need to place in these 4 places are I, R, T and V. So the very first word will be I, R, T, V. Then the next word will be A, I, R, V, T. Then the next word will be A, I, T, R, V. Then the next word will be A, I, T, V, R. In this way, we'll have to find all the words which will be starting with A. So this can be done by arranging these 4 letters in 4 places. Using the formula for permutation, 4 letters to be arranged in 4 places, it can be done in 4 factorial ways. So there will be 4 factorial words which will be starting with this letter A. In similar way, then we'll find all the words which will be starting with this letter I, which will also be equal to 4 factorial. As in this case also, the first letter will be I, and to find all the letters which will be starting with I, we'll have to arrange the remaining letters which are A, R, T, V in 4 places. 4 letters to be arranged in 4 places can be done in 4 factorial ways. So in similar way, we'll have 4 factorial words which will be starting with the letter R and 4 factorial words which will be starting with the letter T. So in total, we'll having 4 into 4 factorial words before we get any word which will be starting with the letter V. So now we have arrived at our series of words which will be starting with the letter V. And before it there are 4 into 4 factorial words. Now our next target is to get the word which will be starting with the letter VI. But alphabetically, the next word will be starting with the letters VA. So now there are 3 more letters that needs to be placed. Which are those? I, R and T. So to get all the words which will be starting with the letter VA, we need to place 3 letters in 3 places. This can be done in 3 factorial ways. So after all the words which are starting with VA, we'll get our next word which will be starting with the letter VI, because after A in the alphabetic sequence we have the letter I, and this is what we need. We need a word to be starting with the letter VI. Now we need our next letter to be R, but alphabetically the next letter would be equal to A. So now we need to find all the words which are starting with the letters VIA. Then we'll get our next word which will be starting with VIR, because after A, since I is already taken, we'll have the next letter as R. So first we'll find all the words which are starting with this letter VIA. Now for that we need to place two more words which are R and T in two places. So this can be done in 2 factorial ways. So first we have all the words which are starting with V, then we have all the words which are starting with VI, which was 3 factorial. Now we have all the words which will be starting with the letter VIA. These are 2 factorial words. So after we have accounted for all the words which are starting with VIA, we'll get our next word which will be starting with the letter VIR. So the next letter that we need after R is A, and alphabetically also A will come next. And then finally there will be only one letter left, which is T, which will directly come in here. So this is finally our word VIRAT, which we are looking for. So before this word, how many words are there? These many words are there. We will add them up, which will come out to be 4 into 4 factorial, which is 24, plus 3 factorial, which is 6, 2 factorial is 2, 4 into 24 is 96, 96 plus 6 plus 2. This will be 104. So there are in total 104 words before this word VIRAT. So what will be the rank of this word Virat? It will be 105. So in this way you can find the rank of any word. So for that you will have to first arrange the letters in the alphabetic sequence, and then by taking the letters in alphabetic order step by step you will have to arrive at the word that you want. Let us now understand how to find the sum of all n-digit numbers using a given set of digits. Suppose you have been given a set of n digits. Let's take for example, you have been given a set of 2, 3, 4, 5. These are the digits. So in this case the value of n is 4. And now you have been asked to find sum of all the 4-digit numbers that can be formed using these digits. So how many 4-digit numbers can be formed using these digits? Since there are 4 digits, these 4 digits need to be arranged in 4 places in order to form a 4-digit number. So this can be done in 4 factorial ways. How? For the first digit you will have 4 choices. You can take any of these 2, 3, 4, 5. Now if you have taken any one number here, for the next place you will be left with only 3 choices, and then for the next place you will be left with 2 choices, and then for the last place you will be left with only 1 choices. So the total number of numbers that can be formed will be given by product of all these numbers, which is nothing but 4 factorial. So the number of n-digit numbers that can be formed using those n digits is given by n factorial. And we need to find the sum of all these numbers. So how it is to be done? Let's see. Let us take this example. Suppose the digits that have been given to you is 3, 4 and 5. And we need to find sum of all the 4-digit numbers that can be formed using these digits. Since there are 4 digits, we can form 4 factorial 4-digit numbers, which will come out to be 24. So there are 24 numbers that can be formed using these 4 digits, and we need to find their sum. Let us consider one digit at a time. If we consider the first digit, let's say 2. So this number 2 can occur in any of the 4 places. It can occur in the thousands place. It can occur in the hundreds place. It can occur in the tens place. And it can occur in the units place. So when this number 2 occurs in the thousands place, what will be the contribution of this number to the sum that we are intending to find? It will be 2000. So when this number is occurring in the hundreds place, what will be the combination of this number 2? It will be 200. Occurring in tens place, it will be 20. Likewise, when this number is occurring in the units place, its contribution will be 2. Now, how many 4-digit numbers we can form such that the number 2 is occurring in the thousands place? So for that we need to fill these 3 digits in these 3 places. So 3 digits to be placed in 3 places, it can be done in 3 factorial ways. So there will be 3 factorial numbers which can be formed such that the number 2 is in the thousands place. Similarly, how many 4-digit numbers can be formed such that the number 2 is in hundreds place? Again, we have 3 vacant places. We need to fill them with these 3 numbers, 3, 4, 5. It can be done in 3 factorial ways. Likewise, how many 4-digit numbers can be formed when the number 2 is occurring in the tens place? 3 places to be filled with 3 numbers can be done in 3 factorial ways. And similarly for the units place, it can be done in 3 factorial ways. So the total contribution of this digit 2 in the sum that we are intending to find will be addition of all these things. If we add them, we can take 3 factorial common. So this will be 3 factorial into 2000 plus 200 plus 20 plus 2. So if we add all the terms in the bracket, it will be 2222. Likewise, in place of this digit 2, had we taken the number as 3, would it make any difference? The only difference will be this 2000 will become 3000. And the number of numbers that we can form with 3 in the thousands digit will remain the same. It will be 3 factorial. This 200 will become 300, 20 will become 30, 2 will become 3. And the same pattern will repeat even in case of 4 and 5. It will become 4000 in case of 4, 5000 in case of 5, 400 in case of 4, and 500 in case of 5. Likewise 40 and 50, and 4 and 5. So if we take sum of all these digits, what we are going to get? 3 factorial we can take common from all these. So we'll have 3 factorial into 222 plus, if we add 3000 plus 300 plus 30 plus 3, we'll get 3333. Likewise, if we add 4440 and 2, we'll get 4444. And in case of 5, we'll get 5555. So the sum will be equal to 3 factorial into, we can take 1101 common from all these 4 numbers. So in the bracket, what we will be left with is 2 plus 3 plus 4 plus 5. Now if you observe, what is these numbers? These are basically the numbers which were given in the set 2, 3, 4 and 5. And what we are doing? We are finding the sum of all the numbers in the given set. So this is basically sum of the numbers in the set which has been given to us. If you notice this 3 factorial, it is nothing but 1 less than the number of numbers in this set. In this set there are 4 numbers, so it is 1 less. So we'll have n minus 1 factorial here. And this number 1101, it is containing 4 ones. So it is nothing but a series of ones. How many times? N times. So the general formula for finding the sum of all the n digit numbers that can be formed using the given n digits will be equal to, sum will be equal to n minus 1 factorial into 1, 1, 1, a series of 1, how many times? N times, into sum of all the digits. So in this way you can find sum of all the n digit numbers which can be formed using the given n digits. So if the given digits were, let's say, 4, 5, 6, 7 and 8. And if you want to find sum of all the 5 digit numbers that can be formed using these 5 digits, so it will be directly, number of numbers are 5, so it will be 4 factorial into 1, 1, 1, how many times? It will be as many times as the number of numbers are there in the set, which is 5. So this will become 11,111 into sum of all the digits in the set, which will be 10 plus 15, 25 plus 5, 30. So all you need to do is now multiply these numbers and you will get your answer for the sum of all the 5-digit numbers that can be formed using these digits. You don't have to go into this detailed explanation part. Let us now understand how to find the number of lines, diagonals, triangles and quadrilaterals that can be drawn from a given set of points. So let us first start with the lines. Now for drawing a line, we need any set of 2 points. So if we have a set of 2 points, we can draw one line. So if we have another point, we can draw 2 more lines. If we have 4 points, let's count how many lines we can draw. So if there are 4 points, we can draw 1, 2, 3, 4, 5 and 6 lines. So while drawing these lines, what are we actually doing? We are taking a group of 2 points. So for this first line, we took these 2 points. For this second line, we took a group of these 2 points. Then for this third line, we took a group of this point and this point. For this fourth line, we took a group of this point and this point. For this fifth line, we took a group of these 2 points. And for this sixth line, we took a group of these 2 points. So what we are basically doing is, from the given set of 4 points, we are selecting any 2 points. So this selection of 2 points out of these 4 points can be done in 4C 2 ways. So this will give us the value as 4 factorial divided by 2 factorial into 2 factorial, which will come out to be 4 into 3 by 2, which will give us the answer as 6. So we can draw 6 lines from a group of 4 points. Now one important point to note here is, all these points that we are taking, these are all non-collinear points. So if there are n non-collinear points, then the number of lines that can be drawn using those points will be given by NC2, where n is the number of non-collinear points. Let us now understand what will happen in case if these points are collinear. Let's say out of these 4 points, 3 of these points are collinear. And there is one non-collinear points with respect to these points. So now if we draw the number of lines, let's say by considering these 2 points, we can draw one line. By considering these 2 points, we can draw one more line. By considering these 2 points, we can draw one more line. Now, by considering these 2 points, we can draw one line. By considering this point and this point, we can draw one more line. But if you notice, this line and this line, they are one and the same, since all these 3 points are collinear. And similarly, if I consider this point and this point, and if I draw a line, it will again represent the same set of lines. So these 3 collinear points are actually contributing only one line. Whereas in normal circumstances, when these points were non-collinear, they would have contributed 3C2, which would be equivalent to 3 lines. So instead of 3, they are contributing only one line. So had these 4 points been non-collinear, we would have got 4C2 lines. But since these 3 points are collinear, so the lines which are formed using the groups of points which are collinear will only contribute on one line. So we'll have to replace these 3 lines by one line. So for that, we'll have to subtract 3C2. So we are subtracting the total number of lines that can be formed by using these 3 collinear points and replacing it with one single line. So now the total number of lines that we can form will be, this is 6 minus 3 plus 1, which will come out to be 4. And if we count it physically, we have one line here, 2, 3, and this is the 4th line. So had there been n points, of which x points are collinear, then the total number of lines that can be formed will be given by NC2 minus XC2. This represents the number of lines that can be formed using the collinear point if we consider them as non-collinear. And we are subtracting these lines and replacing it by one line because they will represent only one single line. So this is the formula for number of lines. Let us now see how to find the number of diagonals. So if you want to find the number of diagonals in an n-sided regular polygon. So let us consider one square. So if you want to find how many diagonals are there, manually we can say by joining these 2 points we can form one diagonal. By joining these 2 points we can form another diagonal. What we are doing here basically is we are again forming lines. So if there are n points, we can form how many lines? We can form NC2 lines. So out of these NC2 lines, there will be n line which will represent the side of the polygon since it is an n-sided regular polygon, and the remaining lines that we'll get will be the diagonals. So from this we'll subtract the number of sides of the regular polygon, we'll get the number of diagonals. So if we simplify this thing, it will become n factorial upon n minus 2 factorial into 2 factorial minus n. So the numerator can be written as n into n minus 1 into n minus 2 factorial, whole thing divided by n minus 2 factorial into 2 factorial. So this n minus 2 factorial will cancel out and we have minus n over here. So if we multiply this thing, we'll get n square minus n. This 2 factorial will become equal to 2. So this will go and multiply with n. We'll get 2n over here, and in the denominator we'll get 2. So we'll get here n square minus 3n upon 2. We can take n common, we'll get n into n minus 3 upon 2. So this is your formula for number of diagonals in an n-sided polygon, n into n minus 3 by 2. So in case of a square, the number of sides is 4. So if you put n is equal to 4 in this case, we'll get 4 into 4 minus 3, which is 1, divided by 2, which is 2. So in case of a hexagon, which is 6-sided, the number of diagonals will be given by 6 into 6 minus 3, which will be equal to 2, the whole thing divided by 2. This will give us 9. So in this way, you can find the number of diagonals in case of an n-sided regular polygon. Let us now see how to find the number of triangles that can be formed using n points. To form a triangle, we need 3 points. So if we have a set of 3 points, we can form one triangle. Now it is important that all these 3 points should be non-collinear. Had these 3 points been a collinear point, we would not get even one triangle also. In case of line, we were getting at least one line. But in case of triangles, we are not going to get even one triangle also. It is necessary that all these 3 points should be non-collinear. Let us now take 4 points and see how many triangles we can form. So these all are non-collinear points. So the number of triangles will be, this will be your first triangle. Then by considering the set of these 3 points, we can form another triangle. So this will be our second triangle. By considering these 3 points, we can form one more triangle, and by considering this point, and this point, we'll form our fourth triangle. So the total number of triangles that can be formed by using 4 non-collinear points will be equal to 4. So again, in this case, what we are basically doing is, out of these 4 points, we are forming a group of 3 points. That means out of these 4 points, we are selecting 3 points. This can be done in 4C 3 ways, which is equal to 4. As I said, all these 4 points should be non-collinear. So had there been n non-collinear points, then the number of triangles can be formed will be NC3. Now let us consider a case in which some of these points were collinear. Let's say out of the 4 points that we have considered, 3 points are collinear and there is only 1 point which is non-collinear with respect to these 3 points. Now let us count the number of triangles that we can form. So here we have one triangle by considering these 3 points, another triangle by considering these 3 points, and we'll have one big triangle by considering the 3 outermost points. So we'll have a third triangle here. So the number of triangles in this case will only be 3. Because if we join these 3 points, what we will be getting is a line and not a triangle. So while counting the number of triangles that can be formed by considering all these 4 points, we are also counting the triangle which will be formed by using these 3 points, which is collinear. So we'll have to subtract that. So from 4C3, we'll have to subtract 3C3. So this will give us the answer as 4 minus 3C3 is 1, which will give us the answer as 3. So the number of triangles can be formed will be equal to 3. So had there been n points, so the number of triangles can be formed will be NC3. Out of these n points, if x points are collinear, then for those x points, we'll have to subtract the combination of the 3 points. So xc3 will subtract, and this will give us the number of triangles that can be formed. Let us now see how to count the number of quadrilaterals that can be formed using a given set of points. Now to form a quadrilateral, we need 4 points. Once we have a set of 4 points, we can form one quadrilateral. So if we have 5 points, let's see how many quadrilaterals we can form. So this will be one quadrilateral by considering these 4 points. Then by considering this point, this point, this point, and this point, we can form another quadrilateral. Then by considering these 4 points, we can form a quadrilateral. Then by considering these 4 points, we can form another quadrilateral. So the total number of quadrilaterals that can be formed will be equal to 4. Now out of these 5 points, had let's say 3 of the points being collinear. Then by joining these 3 points and any one of the external point, what we'll get will be a triangle and not a quadrilateral. So 3 collinear points and 1 non-collinear point will also not give us a quadrilateral. And if out of these 5 points, had 4 of them been a quadrilateral, by joining these 4 points, we'll still not get a quadrilateral. So 4 collinear points will also not give us a quadrilateral. So had there been n non-collinear points, then the number of quadrilaterals that could be formed will be given by NC4. Now out of these n points, if x points are collinear, so out of these x, we have to select 3 collinear points, which can be selected in xc3 ways. And since and is there, we'll have to multiply 1 non-collinear point. So the number of non-collinear point will be n minus x. Out of these n minus x, if we select any one of the non-collinear point and join it with the 3 collinear point, we'll still not get a quadrilateral. So we'll have to subtract this case. And in addition to that, we'll also have to subtract the case where we join 4 collinear points. So if we join even 4 collinear points, we are not going to get a quadrilateral. So there are x collinear points. So if we join any of the 4 points out of these x collinear points, we are not going to get a quadrilateral. So the number of quadrilaterals that can be formed using n points out of which x points are collinear will be given by this formula. NC4 minus xc3 into n minus xc1 minus xc4. So I hope you are able to understand this concept of rank of a word, finding the sum of all the n-digit numbers that can be formed using a given set of digits, and how to count the number of lines, diagonals, triangles, and quadrilaterals. In the next video, we'll solve some problems based on these concepts. Thank you.